Good afternoon. Welcome, New Orleans. Thank you so much for hosting us. And thank you so much for joining us for today's session. I know a lot of you will have skipped lunch or at least hurried through that. So we're really thrilled to see so many of you here today at our session here today, Accelerate Your Advanced Analytics, R, Python, and MATLAB. Now, I'm pretty sure you've already seen this slide, hopefully when you made your decision to visit our session today, but we just want to reiterate what today's session will be about. We're going to talk a little bit about R, Python, and MATLAB. Today's session is really an introduction to Tableau in combination with external services and the opportunity that allows us to have when we combine those two platforms together. We'll talk a little bit about how you set that up, and we'll use some example use cases and some tests accordingly. Now, today's session has been listed as an advanced level, but it is actually the only advanced level session in this year's data science subtrack, meaning that today we will show you a little bit about all the opportunity that you can have. We'll also give you some pointers towards some deep dives that you might be interested in regarding whether you like R or Python or you want to get your hands dirty during some hands-on sessions. Today's session is really for those people that might be that little kitty cat coming into the world, bright-eyed and really want to see what's possible. There will be that mama cat guiding you along. Now, a few household remarks as well. Today's session, of course, is recorded, like most sessions at TC, so feel free to take all the notes you want, take all the pictures you want. But if you just want to sit down and watch the session, that's fine as well. You'll get the recording, you'll get the PDFs and the slides afterwards. As you can imagine, with both R, Python, or actually MATLAB as well, of course, there will have quite a bit of things to go through. So we do ask you to hold questions till the end, but we promise you that we will make sure that we answer some questions.
With that all having been said, let's talk about how we're going to break down today's session. We're going to actually start off with looking at what Tableau has built in, just as a bit of a primer so that we understand what things we don't have to recreate. But once we've quickly surveyed the things that are available, we're going to bridge off into new worlds using our external services connection. We're going to look at different use cases that build upon these different technologies that Tableau is able to connect with, particularly using live calculations to these different environments. We're also going to cover, during this session, when you should be thinking about using materialized calculations. So not necessarily using those live connections where everything is being recalculated as you are opening up the dashboard and sending off that data. We are as well going to try to give plenty of time here for Q&A, as there might be quite a lot of material that we'll cover. We'll be happy to go in more depth during that particular component as well. And then we're just going to summarize so that you feel that you have good signposts for where it is that you might want to go with your journey after this session and during the rest of conference, and of course looking at the material once conference is over. With all that having been said, though, I don't think we've really introduced ourselves, have we, Irvin?
No, I don't think so.
So let me go ahead and begin by introducing myself. My name is Eric Polano. I'm an associate solution architect at Tableau. I've been at the company for a little bit around 2.5 years now. So I work within the professional services section of our company, meaning that I spend a lot of my time on the road or working with Tableau. But when I'm not at the office, I sort of have an unhealthy obsession with automating different components of my household. So I've been installing different light bulbs all over the place that I now control with my smartwatch, which I'm not sure exactly what problem that solves in my life that I had before. But it's something that I really enjoy doing, and I don't know, I get a lot of pleasure out of it.
I know, he also gets a lot of pleasure for being an aspiring blues brother. Anyway, my name is Aaron Villar. I am a product consultant, and I'm the team lead for our wonderful product consultants back from Tableau's London office, and we cover the Benelux, Nordics, Middle East, and Africa region. So quite a big patch. My background isn't in tech. My background was in healthcare. Started out as public health manager in an occupational health service back in Holland, where I'm originally from. But it wasn't until I became a customer of Tableau and really started to unlocking the value in my own business that I actually moved to London and started working for Tableau. And Eric Polano here next to me is actually my conduit into the wonderful world of advanced analytics.
So let's talk through around what the objective of analytics really is. If we think about it, what we're really trying to do is to create interactive dashboards. And we want to be able to do this without necessarily having the consumer of those dashboards needing to understand the code of how we built this, right? These should be enabling them to answer different questions, particularly with regard to such questions that might not be contained in the underlying data source. But how do we go about doing this?
There's a lot of things already built in Tableau. We all know that calculations can run on a row level, right? We can just say profit divided by sales and we'll get a profit ratio, or at least on a row level. But it doesn't restrain itself to that. We can do difference between days by just saying, well, ship date minus order date will give me the number of days between two particular dates. And then we do that on the row level. We can also move that up into aggregated calculations with, of course, the main component here is that we can take that profit ratio and wrap it up into sums. So doing sum of profit divided by sum of sales, giving us a profit ratio across multiple rows, in which then the dimensionality of the view becomes important. But there's a lot of different types of calculations that we already offer in Tableau. First of all, we have level of detail calculations. They are actually really, really powerful. They're basically nested SQL statements in which we can do potentially some cohort analysis like we see up here. We can literally say, well, fix for me, for each customer, that minimal order date. So Tableau will then return cohorts of people in the years in which they became customer, allowing us to do analysis about customer retention, but also how many new customers do we get into our business. If you're not familiar with LOD calculations, I would highly recommend seeing a session about that. The JEDI LOD stats is this year given by Leah Purdy, which will be amazing. But beyond level detail calculations, we also have table calcs. These are special in the sense that they're being run based off of the values that are already in the view. So if I want to do a percent of total, we'll do the sum of sales, which gives me a value for a particular mark, and then I divide that by the total sum of sales. The total there being that it's the sum of all the marks within the view. Now keep an eye out for table calculations because they will become very important when we're talking the external services connection. The calculation of a table calc is one thing, but then the second thing, of course, is the direction of that computation. So if we're looking into the product, we have these table calcs already available as quick table calculations. So you just select a measure, do a quick table calculation, and select percent of total. But we see that they're being run across a table horizontally. So we can tell Tableau the direction of the computation that this will run, either across, maybe we want to run it down, or across the entire table. Once again, these table calculations will become very important when we're talking external services. Now we already have, of course, analytics objects, looking at reference lines, trend lines, and things like clustering and forecasting. We can grab clusters, drop it onto the view, Tableau will run a k-means clustering, and give us the optimum number of clusters. We can still force it to make 3 or maybe even 4 clusters, or personalize that a little bit, but there's already a drag and drop feature allowing our end users, without coding and scripting, to interact with advanced analytics. And the same goes for forecasting. You grab forecast, drop it onto your view, Tableau will run an exponential smoothing algorithm, picking the right model and giving you a seasonal pattern.
But what if I want more? Think about that there might be a whole number of different use cases within your organization that might not be covered by those drag and drop functions that Tableau has natively. For instance, you might want to run more complex models. You might want to iterate away from the standard that we have, for instance, with clustering, away from k-means. You might find that there are certain instances where you need to have models that have been trained on your specific data, which of course Tableau wouldn't be able to pre-build for you, but that you would want to be able to still bring into Tableau. In general, you might just find that you need a great deal more flexibility than what these built-in analytical functions offer. And that's where our external services with R, Python, and MATLAB come in. So if we think about that objective of analytics again, what we're really doing here is we're adding an additional step by leveraging an advanced analytical language such as those three that I mentioned to send off that calculation and receive the result back for the analysis that we want to do.
So let's talk about those external services then. We started off in version 8.1 by releasing our connection to R. We continued our innovation by allowing you to connect to Python and write Python code in Tableau in version 10.1. Then somewhere in the middle of last year, we added MATLAB to our external services connection. or at least that family of connections that we offer. So how do we call upon one of these functions? And we do this with script functions, and you can find those in the calculated field editor. There's 4 functions that you can leverage: script bool, int, real, and string. The script function, of course, meaning that we're going to call upon an external services. And then the end bit is just stating the type of output that Tableau is expecting to come back from that external service. So in the case of Boolean, it's a true false. Integer, they're whole numbers. Real are decimals, and of course string is text. And of course, and that's what I already mentioned, it's important to know that these will run as table calculations, meaning that the values in the data frame that Tableau will build are based off of the level of detail and aggregation that we have in the view at the time.
Now that we have a little bit of the theory around how these calculations are available to us in Tableau, let's go ahead and look at an example together. Within this example, I'm going to be breaking down some code that I've written in R, and I'm going to be looking at how to bring that into Tableau. So what I'm going to be doing in this case is I'm going to try to run a certain type of forecasting library from R. Because it's a forecast that then can be any type of number that's defined within the real domain, then that's of course a relevant use case for me to use script real. I begin here this calculation by calling that library, by opening up my double quotes, and within the next line, I define my data frame. Here, you'll see that within my data frame, I have 3 variables that I'm pulling in: y, x1, and x2. Pay attention here to the fact that we also have these mappings to these different arguments: arg1, arg2, and arg3. All that I'm doing here in the middle is I'm just going to count the total number of observations that I have within that data frame, and I'm then going to just simply divide up into a period before my intervention and after my intervention. After that, I'm just going to call in here my objects, impacts. I'm going to bring in the different aspects of that data frame, and then I'm going to use that object to then get my point predictions within this particular calculation. Now comes the important part. What we are going to be doing in terms of bringing in these calculations from Tableau is we're going to use these different fields here that are all aggregations to map those into this calculation. So my sum of profit in this case is mapped into arg1. Sum of quantity is mapped into arg2. And sum of sales is mapped into arg3. All of these positions that we're referring to with these arguments, as you can now see, are all just mapped into that particular position that that field ends up in. And in that way, we're able to use the calculation, send it off to this external environment, in this case R, and then receive the results back once we've defined how these particular fields should be then calculated on a particular level, given, as Irvin was mentioning, that these are table calculations.
So we have our scripts and we want to run them. How do we actually connect Tableau to that external service? So within desktop, you just go into help, settings and performings, and there's an option there that says manage external service connection. A new text window will open up, and it will allow you to point Tableau towards the server your external services is running on. In this case, it's just a local host, and for R, the port that it's currently or usually running on is 6311. You can, of course, specify it to be somewhere else, but that's usually the default. And if you want to, you can add your username and password if you want to. If you then test the connection, Tableau will say, well, we've successfully connected to the rserve instance. But what is that rserve instance? And what does that connection actually mean? On the one hand, we have Tableau, whether it's desktop or server, and on the other hand, we have those external services. What is actually happening between that connection? Well, it all starts with data. I mean, it's a big data conference, so that's probably where it starts, right? And we use Tableau to connect to any data, all data, wherever that sits. Because we use Tableau to build that data frame for us. We then have to put in an external service or an agent that we can call upon. So in case of R, that's an rserve instance. In case of Python, that's a tabpy. And in case of MATLAB, that's the MATLAB production server. From Tableau, we will then run that script function and the data that we've built in that data frame. and send it towards that external service, who will then forward that on to the environment we want to use. The calculations and the predictions are made, and the results are being sent back through the external service, who gets it back into Tableau, where it's instantly visualized. Sounds easy enough, and these were just slides. So let's start talking about all these services one by one, just in specific cases. And let's start with the first member of that family, which is R, matey. Anyway, R. We already talked. If we want to connect Tableau to R, we bring in that external service, which in this case is RServe. It's nothing more than a TCP IP server that allows other programs to leverage the calculations that we can run in R. Now, one of those examples, so we already said we were going to show you a few examples live as well, is that Tableau allows us to help see visual patterns in data. But we also want to calculate whether or not those patterns are significantly different. Now, just a basic test, the absolute basic of statistics, could allow us to answer that question, which would be a t-test. I think that will be a perfect opportunity to have Eric show you that live.
Thank you, Urban. Let's switch back here into Tableau Desktop. And what I'm going to do is I'm going to first make sure that I have here my favorite IDE for R, RStudio, where I have, in this case, installed certain packages, RServe, and my forecasting package. And I'm then going to call that RServe package and start running it so that Tableau can interface with R. In this case, I'm just going to now have this be run so that I know that my RServe is available. I see here at the bottom that it is. And what I'm now going to do is to switch back into Tableau Desktop to make sure that I can then connect to it in that way that we were looking at. So I'm going here to External Service Connection. And within this instance, I now see that I have defined it as localhost, because I'm just running this locally on my machine, and 6311, which is the default port for RServe. I test this connection, and I see that I've successfully connected into my RServe service. Great. So in order to maybe look at the future of how we can embark upon this journey for looking at how we can do analytics within Tableau, maybe we should look at some of the history relating to statistics. Within the early 1900s, there is a budding young chemist who's brought into Dublin to work in a brewery to test if there are certain inconsistencies with the qualities in the batches that have been involved there. Now, the types of tests that were available at that time using Gaussian distributions would require an enormous quantity of beer to be used up in this, which of course was a big cost. So
Did you do your master's in Dublin, Eric?
I did, in fact, live in Dublin for quite some time. Though I want to say this is totally coincidental to knowledge of statistics here.
That's good. Good to know.
Within this case, what it is that we're looking at is the possibility to compare different batches that come out at similar time spans to then be able to compare whether the quality is consistent between these different batches. What I'm further able to do in this case, so within here, in each of my panes, I see in a given time period what here between my south and north batches from the different plants within that factory. And I see that there are certain inconsistencies maybe in some of these, but I want to be able to judge whether or not these are in fact the same, or if they're different in terms of their consistency. And what I'm getting here at the very top is that value from R, which is my p-value, to determine whether or not I can reject my null hypothesis of these batches being the same. Because this is, of course, an interactive dashboard, what it is that we want to be able to do is, of course, see, well, what about if we switch here to a different time span so that we, for instance, look at a shorter time span and see if we have a different result? Well, here we are actually able to reject that null hypothesis, but that's a really short time span for us to maybe be able to make such a claim. Maybe certain observations here need to be increased in order to get us more statistical power. So if I increase the full span to include a longer time series, I see here that I'm actually able to judge this test differently. And again, I'm able to interact with all of this without really having to know, as that end user, that that R code is what's powering all of this underneath. But let's go in and understand a little bit around how we build this calculation so that you can see this live as well. Within this case, what I'm going to start off with is I'm going to create a calculated field that I'm going to now use to calculate that p-value. So I'm going to call this my p-value. And just like with that forecasting example, I know that I have to use a script real because I have numbers here that are contained within the real domain. I now begin by pasting in that piece of R code. So I define here my t-test, and I now want to go ahead and start using those values that I had for my factory south and factory north. So I'll bring in factory north here to be my arg1, and then I'll do the same here for my factory south. So when I just drop this here into my field, I now see that Tableau gives me a prompt to say that this calculation is valid. Great. And what I can now do is I will bring in the fields that are needed for me to be able to perform this calculation. So because I'm doing this here between all of these different batches, and that is then here my time series, I'm now going to bring that first field here in onto detail. I'm then going to pull here my p-value over onto text, and before I let this calculation run, what I'm going to do is I'm going to tell Tableau that I need this calculation to be addressing my beer batch, which I've put here onto detail.
Which is that table calculation that we talked about earlier when we talk about the direction of the computation. That's what Eric's addressing right there.
So on that exact point, I'll now let Tableau run this calculation, and now I can see that I have returned that value, which I'm just going to make a little bit bigger here for us, which is the equivalent of what it is that we're looking at before. Now, you're thinking here probably, OK, this was a t-test. But what about if we want to push this further into different directions? So just as a further example, let's switch back here into our forecasting cockpit, where we're using here different types of forecasting methods to be able to look at, for instance, what our sales are dependent upon our marketing spend and our number of salespeople. Within this instance, I'm just going to quickly jump in and see here within this case that I can evaluate what my predicted sales are, for instance, by pulling in a much more complex calculation by just mapping in here these different economic indicators. So what we were looking there is inputs for my particular business and my end result sales. All that this is pointing towards is that you're really opening up a much broader world of defining how, for instance, in this case, we're using an ARIMA model as opposed to the exponential smoothing that we had built in natively to really augment the type of analysis that we're able to do here within Tableau.
That was R. For those of you that want to get down and dirty, this is one of those moments where we really want to point you towards some other sessions that are running this year's at TC, because we actually do have the widest data science track ever at TC. I know it's currently standby only, but two of our amazing colleagues from London, Mo and Rachel, are running, Konstantin and Leonard are running Jedi Stats Are You Ready? They're from Germany, and they're quite amazing. But even if you can't get into the session, the materials to that hands-on might be available after TC. So if you want to get hands-on, get dirty, really get working with the product, we would advise you to attend that session, or at least look at the material. And with that, let's move on to the second member of our external services family, which is Python, which is a language some of you might prefer above R. So talking a little bit about the setup, we no longer, of course, use an rserv instance where we want to connect Tableau to Python. In this case, we're going to use TabPy, which is a client that's going to allow us to do so. You can find TabPy, which is a Tableau Python server, just on GitHub. We have an entire page available for you where you can find the code and how to install that. The resources will also be in the slide deck, by the way. Now, sometimes you don't really want to get down and dirty and know how to install it, so one of our amazing colleagues, or ex-colleagues at this point, also created a Docker container that will actually just install for you the latest version of Python, and also install these widely used packages as you're going along. So all you have to do is run that Docker container. It'll get the latest version of TabPy and these packages pre-installed.
So why don't we go ahead actually and look at that particular example? What I'm going to do now is I'm going to switch over to that particular example that we were looking at, that he was mentioning, with regard to that Docker container. Because all that you really need here, if you wanted to have this set up, you could follow what it is that we have here on GitHub to set up your TabPy client and your TabPy server. But an even easier way is here to just look at, for instance, the TabPy Docker image set up here. And Erwin was mentioning those different packages that come pre-installed. But if you wanted to add in those, you could easily just add in different packages to be pip installed here into that Docker image. In terms of just having a little bit more of an ease of setting all of this up, I'd highly recommend just having this set up if you're looking for something quick and easy to prototype with. But given though that we've been mentioning this Docker image, let's actually look at this particular instance where I've in fact started that Docker image here on my server locally. So all that I've done here is that I've started here with Docker, that particular image, which I've then pulled from GitHub, and I've started up on port 9004. In order for me to be able to use this, let's look at a particular use case that actually leverages this particular running Docker instance and a Python package. I'll switch back here into Tableau, and now I'll go ahead and switch over to my Twitter sentiment analysis here with Python. Now, before I'm able to make use of what is here within this particular sheet, I need to make sure that Tableau is in fact connected into that particular service. So it's still running locally, so I'm still going to use localhost for my server. All that I'm going to do is I'm going to switch out that port to 9004. I'm going to test this connection, and sure enough, I'm successfully connected into that predictive service now. What I can now do is that I can switch back out. I can let then this calculation be sent, and I can see now that Tableau is able to send these different common texts that I have into that Python environment, and they can then be given correspondingly a sentiment score. If we just quickly jump into that sheet, what it is that we'll see is that many of the principles that we were looking at that with regards to R remain very much the same here with TabPy. All that we need to do within this instance is to look here at the process that we would use now using Python code. So within this case, what we're doing is we're importing our sentiment intensity analyzer from Vader sentiment. We're just opening up that particular VS list, and then we're simply defining a loop that appends that particular sentiment where we've then pulled in that common text into our first argument. Now, one thing that I just want to highlight here as well is that we still need that aggregation to happen despite this now happening essentially at the row level in our data source. And that's the reason why we're using the attribute function. This all means that we can now address the common text level that we have within this data set, and then we're able to run this particular piece of Python code seamlessly here within this particular case.
And that was Twitter sentiment analysis. And this is actually where Mohammed and Rachel come in. They run a session called Tableau plus Python equals love. I think that one's standby only as well, but you can always try or look at the materials later on. Moving on to MATLAB, the newest member of our family. Now, MATLAB we can obviously connect to, but it's a little bit different in the sense that it offers two different options to connect to MATLAB. First one being using the external services that we can use when we're talking R or Python. The other option that they offer is the web data connector. Let's talk a little bit about the differences between the two. First one being the external service connection. And MATLAB is a little bit different than R and Python in the sense that you define your entire function on the MATLAB production server side. So for MATLAB, we're not using our server TabPy, but we're using the MATLAB production server. The calculation in the calculated field in Tableau is actually just a script that you're calling upon and the measures you want to bring in from Tableau. All the other scripting takes place on the MATLAB side. And we just call that function once again using those script functions from Tableau. Now, of course, there's the possible to filter and rerun those calculations on the dashboards every time you connect to them. The advantage there, of course, being that it's a lot more flexible. Every time an end user comes in and maybe changes some values, or as Eric changed the dates on that beer batch example earlier, those calculations will be rerun. But the other option for MATLAB is to connect to their web data connector. So we request once the data at the initial data source stage. We send that to MATLAB, and all the results are written in row-level extract. Now, how does that actually work? So Tableau sends that request. It's just an HTML request using the JavaScript API, or at least the JavaScript. And we call upon MATLAB, who then writes or creates that extract or the results and put that in a JSON file. The web data connector for Tableau then puts that JSON into an extract, and then that extract's available for us to use. The advantage, of course, here being performance, because all of our results are row-level written into that complete extract. And we can use that data regardless of the aggregation level. If we want to aggregate that up, we can do so. So let's look at an example. And it was that screenshot we showed earlier.
Let's indeed.
Yeah.
In this case, what I'm going to do is I'm going to switch here into a Tableau server instance. And this Tableau server has been set up so that it's connected into a MATLAB production server. If we look here at this particular sheet, what it's doing is that it's running here an optimization problem where it's trying to understand what is the shortest path between each of these different cities. Now, because this is set up with an external service connection, it means that when I interact with this particular visualization, it'll then recalculate if it is so that I want to, for instance, see what my path would be if I would exclude certain cities. So because of the fact that it can then recalculate these results, as Tableau just refreshes that with those filters now applied, I don't have to worry about the fact that some of these things could be written into my data source. But beyond this component of looking at whether or not something is using a web data connector or an external service connection, let's look a little bit underneath the hood here so we understand some of the key differences between how our MATLAB integration works relative to what we were looking at with Python and R. Within this case, what I'm going to be doing is I'm going to pull in here my shortest path, and I'm going to just highlight here that we don't have that much MATLAB code running here within this calculated field. As Irvin was mentioning, because we define most of these calculations already on the MATLAB production server side, all that we're doing in this case is that we're putting in the fields that are anticipated by MATLAB, by that code, and then we're able to call this function and have Tableau show the live results from those calculations. To show a further example of what it is that MATLAB really allows for, let's switch out of this particular case and go into our portfolio optimization problem. Now, because, of course, that MATLAB is readily used within many, for instance, cases surrounding financial analysis, you might want to look at, for instance, maybe having a dashboard set up that makes use of some of those advantages that MATLAB offers for. So if I go in here and I look at the web edit function, which again, there's no reason to restrict the development of all of this within Tableau Desktop for some of your users if they want to test things out here within web edit. I can see here that the calculation that I use for my MPS weights is again very similar to the function that I was calling within my shortest distance example. So here, I'm simply calling in that MATLAB function to optimize my portfolio, and at that last step, just calling out these attribute functions for my index names and my index values.
And of course, because we publish these dashboards onto server, it then opens up possibility to start business users having interaction with these dashboards. They can start inputting information based off of their knowledge about the business and interact with the view. Or it opens up new opportunities regarding embedding and really leveraging dashboards that leverage these languages in an embedded solution that you might want to open up. If you have more questions about that or are interested in that, there's going to be an embedding data science for self-service analytics session starting tomorrow as well, run by Blair and Santiago. So we've looked so far to live calculations, calculations that are run live on the dashboard based off of those the values in the view. But sometimes there's a need to just make sure those values are already materialized, like you would do in the Web Data Connector option for MATLAB.
Let's run through some of those particular examples that lend themselves very well to having these things be written into the data source as opposed to being recalculated live as we're going. For instance, that Twitter sentiment analysis component that we did with Python. There was actually a good example of something where we could have, in fact, written those things into the data source, right? No matter how many times that you might look at a particular tweet, you're not necessarily going to reclassify that tweet sentiment unless you run an entirely different algorithm or different type of neural net to classify those. You might also think about cases where you might want to identify certain attributes surrounding your customers that are, again, not exactly dependent upon what it is that you happen to have in the dashboard or in your view at any given point in time. Here, there's always that trade-off to be made between whether or not you think that you're going to actively be reclassifying something. For instance, you might think about cases where having different clustering algorithms become highly dependent upon what it is that you filtered on. In those cases, the external service connection makes a whole lot of sense. In general, the guiding principle would be, can I figure out a way to make sure that what I'm running here can be done on the row level and can be referenced in a way that makes sense in my dashboard? If so, materializing my calculation might be the way to go.
And there's an example that we just want to touch upon. This is a real-life example, one of our customers using this. There's a caveat when we're talking about large volumes of data. Because the calculations are running as a table calculation, if you have an optimized big data database that just spits out those values real quickly, the values will be calculated as quickly as a small Excel file, right? We're just running them based off of the values in the view. But this example is from ABN AMRO, from the clearing department. There's a quantitative risk analysis. Her name's Marleen Meijer. She presented at our Tableau conference in London back in July. And they clear about 16 million trades a day. Now they run a correlation haircut model to detect pricing anomalies. And they use that on all assets. Now, there's usually not a use case to run 16 million trades, or at least that price anomaly detection on a dashboard having 16 million marks and only being interested in those that are being detected as an anomaly. So they pre-calculate that, they run a Spark instance that calculates those values, and the dashboard actually only spits out those values that are detected as an anomaly. Now, Marleen also has a really great Google Forms application in her dashboard that allows end users to also feedback whether or not the detected anomaly was actually an anomaly or not. And that form is being sent back to Google, and that values are being picked up daily, continuing to train the model, making sure that it becomes more valid over time. In general, that was a use case, and if you're interested in this session, it will be in the resources as well. It was recorded. It just made their machine learning project a success. Tableau was a way, in this particular instance, they wanted it to pre-calculate those values, to really bring machine learning to life at a big bank. At this point, before we're going to summarize, There's, of course, one final remark when it comes to materialized calculations. We just have to wing this one because the announcements was, of course, this morning. Tableau Prep will have R and Python on the roadmap. So hopefully Tableau can really assist you on your way to really materializing those results as part of your Tableau deployment. We both shrieked this morning with a little bit of joy when we saw that announcement. But we were really working to make sure that we support you both in those live calculations as well as potentially creating those extracts and materializing those row-level results. But before we go to the summary and wrapping up what we discussed today and showing you all the sessions on offer, are there any questions at this point? There's no mic, so just scream them and we'll send them back to the room. I see one over here. Yeah. 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 Great. So the question was, we have an rserve instance running. Would that always have to be running? The first part of the question. And the answer to that is yes, because we need R we need Tableau to have a place to send those results to R. So yes, that is needed. The second part of the question, are those dashboards then publishable? Answer to that is yes as well. You can have Tableau server hooked up to that same R instance, meaning that your end users can just go through dashboards as they normally do on Tableau server, and then Tableau server picks up that connection to R. So they don't even have to have a client running, you just set that up in the background. It's a brilliant question. We'll come back on that later because Eric and I have another session which literally talks about R and Python on server. I see one at the front here as well.
So I'll just repeat the question for everybody else in the room. If I understood your question correctly, it was, can Tableau server users start an entirely new workbook that makes use of Python calculations? And the answer there is yes, because as Irvin was explaining a little bit before, once you have the service connection established between Tableau server and whichever external environment that you want, in the same way that we were looking at the MATLAB cases, which was using web edit within Tableau server, you could do the exact same thing with Python. So then you would just be leveraging the fact that Tableau server is already connected into an external service, and web edit then functions with that parity between Tableau desktop on the basis of our external services connection. So with Tableau server, what it is that you need to configure is you need to set where this QL external service is going to be connecting to with its host name and then its port. Once you've then applied those changes and you've restarted your server, that's all that you have to do. And as a further point though, and this is something that we cover in our other session a little bit, if you wanted to have people running, for instance, certain workbooks that were using R and other ones that are using Python, what you can do is you can have, for instance, an intermediary point that routes different requests depending on what, for instance, the first line of code is. So there are, for instance, one very large German chemicals company that uses this particular workflow of just having different beginnings of calculations that define where the external service connection is then going to be sending things to. Questions here at the front?
Yeah. So the question is MATLAB faster or more flexible than the connection to R? Flexibility from a Tableau standpoint.
I would say that there isn't really that much of a difference. The main flexibility that you get with R and Python is the fact that you essentially, by necessity, will be doing more of the definition for your calculation in the calculated field than what you would on MATLAB, because their things by design have to be pre-configured on the MATLAB production server and just be ready for Tableau to send those calls for those specific functions that we were looking at.
Yeah, from a feature functionality perspective from Tableau, it doesn't matter. It basically comes down to a personal preference or a preference for a particular platform. Like MATLAB's widely used in financial services or image processing, those sorts of things. You might want to leverage a particular language at something it's really good at. We'll have one more question here, and then we'll do the summary.
On your external services, when you connect the local rollers to a specific port,
Mm-hmm.
you basically just wrap the function in some of the native code for like Python or one of the other services. Can we use any sort of like IGRPC from Google, from the microservices library, or Node.js, and connect to that host on that port and just wrap that code that's required, not necessarily for MATLAB or Python, but for Node or whoever's hosting that connection? You can use Google IGRPC to connect to any library. There's almost hundreds of thousands of them. And that's just pointing to the hosting port.
So the question for everybody else in the room was broadly, what sort of flexibility does Tableau offer with regards to connecting to external environments that are set up somewhat differently than what we were looking at here within this? I would say, in general, there's nothing stopping you from having a separate instance that, for instance, might be spun up with specific libraries. I think with regard to your specific case, happy to speak offline to see what things we could probably help with. But I'd say most of the time, whatever you can send in that calculated field can be used, of course, to also define what libraries or packages are going to be called in that particular environment.
Like you guys are using just like an intercom C++ and passing that data in.
Yeah.
And then whatever the deal is, it just responds. And that's how you're wrapping that.
Yeah, effectively.
Cool. We'll stick around for questions after the session, but let's just do the wrap-up and the summary for now.
So, on that point, let's talk a little bit around what do external services really bring to Tableau. And what I really hope that you're leaving the session in understanding and feeling here is that Tableau really does have the possibility of engaging people with much deeper questions with regards to how you do your analysis. It's just about setting up the dashboards in the right way. When we're looking at how Tableau can leverage what it is that your data science team has maybe been building with regards to machine learning and having certain models be pre-trained, Tableau is absolutely able to interact with all of this. It's just, again, a matter of understanding what is the appropriate workflow for this. Do I want to use a calculated field that will be sending things live? Or is it sufficient for me to just be calculating into a data set that has already these things materialized into the data source? I think in general, what it is that we're sort of enabling within this is to really spread out how, for instance, the work done by your data scientists can be evaluated and seen and very much also be engaged with a much larger audience of Tableau users. In general, I think the expressive power that you are offered by looking at all the different ways you can make interactive dashboards premised on these more deep and nuanced questions that these external services allow for really opens up a whole new world of possibilities.
And that's what external services bring to Tableau. But then, of course, the question also becomes, what does Tableau bring to external services? First of all, it's data connectivity. We can leverage the fact that we can connect to any data, wherever that resides, into Tableau, and have Tableau send that data on. We all know that if data is in a CSV, we can quite easily connect to it, but when we have to have joins and data prep, it becomes a little bit more difficult. So we can leverage Tableau there. We can still explore at the speed of thought, and not just us, or not just your data scientists, but also your end users, especially when you start publishing those dashboards up. And it just helps with interactive visual storytelling, regardless of whether or not you're leveraging an external service. Now, the other value that Tableau actually brings to external services, so you might all be using your Shiny apps or something like that. The moment you publish a workbook onto Tableau server, it automatically inherits all your governance and your security settings. So if you leverage row-level security, your one publication of your forecast will automatically only show for your particular regional manager the region that they're responsible for. Instantly, it adheres to your company and organization's security metrics. Basically, the conclusion, we hope you've at least seen a little bit of what Tableau can bring when you start exploring or connecting to an external service. And hopefully that little kitten inside of all of you has really sort of grown their manes. So if you're going to dream big, have fun, just connect to it, see what's possible, engage business users, and really start unlocking more and more value. Now, as we said, there's a bunch of related sessions. It's the biggest data science track at TC ever. Shameless plug at the top there. Advanced Analytics at Scale is me and Eric's other session in which we talk about how do you bring together the world of the data scientist and the business user and use Tableau Server as a world where you can really start unlocking more and more value. As we already discussed, Tableau plus Python equals love is a hands-on done by two amazing colleagues from London. But if you're more of an R user, you can go to Are You Ready? Jedi Stats with R in Tableau done by Leonard and Constantine, which will run tomorrow at 10:15. If you want to look at, for instance, embedded use cases and the nuances that come with embedding an external services in your dashboard, go to Blair and Santiago's session tomorrow at noon, right next door in La Nouvelle Ballroom B. Or if you want to go scripting and really coding and seeing some real life use cases, also debugging code, go to Data Science Applications with TabPy and R, which will be hosted by Nathan Mannheimer, our product manager for external services. So if you really want to go to a session hosted by one of the guys that built these connections, it's definitely a session to check out. Also tomorrow at noon, I think that one will be repeated as well at New Orleans Theater B down the hall. And if you know people who might be interested in seeing our session, this session will be repeated in this room here tomorrow. One thing, and you'll see this on every slide this year at TC, but we do mean it, please fill out that session survey that you can find in your TC18 app. We really read those reviews and keep expanding the sessions and really read them. So if you thought it was amazing, let us know. If you think it could be improved, also let us know. If you thought it was nothing, maybe see another session, I don't know. No. Also let us know. We really genuinely read them. So we thank you in advance for filling that out. And with that, we genuinely thank you for your attention and staying on during lunch. And we wish you an absolutely amazing rest of conference. Thank you.